Hi everyone, learning chemistry with Daddy Shark. So today we are going to learn elements in period 3. Before we proceed, disclaimer, the video is for the education purpose for Form 4 and Form 5 students in Malaysia. It is hoped that all the diagrams and examples would provide you a better understanding. So what is period? So periods are the horizontal rows in the periodic table. So there are 7 periods in our periodic table. And when across the periods from the left to the right, we said that the proton number increases by 1 unit from one element to the next element. So this is what you learn in 4.1. So when we arrange the elements, we arrange in order of increasing proton number. So my question now, where is the location of proton in an atom? Do you still remember? Where is the location of the proton in an atom? Yes, actually the proton is located in the nucleus of an atom. So now, look at example number 1. So can you give me the electron arrangement of the atom of sodium and the atom of chlorine? So how do you write down the electron arrangement? Without referring to the diagram, how do you write down the electron arrangement? So first of all, we have to determine the proton number. So this is the proton number. And bear in mind, in a neutral atom, the number of proton equal to the number of electron. So let's say, so now we look at the proton number of sodium. If sodium has 11 proton number, so that means the number of electron in an atom of sodium should be 11 as well. So if you want to arrange the electron in order, so how do you arrange this one? So 2.8.1. So how about this one? 2.8.7. So now if you compare these two elements, which one has more proton number? Chlorine atom, right? So if the proton number is more than the sodium atom, if the proton number of chlorine is more than sodium, so we said that the positive charge of the nucleus in which atom is higher. So remember, proton always carry positive charge. Proton always carry positive charge. So if the proton number is higher, so we say that the positive charge of the nucleus in chlorine atom, so this one should be chlorine atom, is higher. So when the positive charge of the proton of the nucleus is higher, we say that the force of attraction of the nucleus on electron is stronger. So what happened here? What will happen here? We say that the force of attraction of the nucleus on the electron is stronger in which atom? In chlorine atom. So this will cause the atomic size of chlorine to be smaller. So today, the first thing I want you to remember is across the period 3, the atomic size becomes smaller. So as you can see here, so 0.186 nanometer until 0.094. So actually I get this table from your textbook. So the first thing you have to remember for today is the atomic size becomes smaller when across the period. Means when we move from left to the right. So how do you explain this one? Because what number increases by 1 unit from one element to next element? What number here? So remember, the proton number increases by 1 unit. So when the proton number increases, this will cause the proton will carry positive charge. So this one should be positive charge of the nucleus will increase as well. So when the positive charge of the nucleus increase, this will cause the force of attraction of the nucleus on the electrons becomes stronger. So the atomic size becomes smaller. So you have to learn how to give the explanation. So now I give you another example. So now can you determine which one has a smaller size? Which one has a smaller atomic size? So I give you the electron arrangement. So you can notice that in these two atoms, you have 3 shells occupied by electrons. So in this case, how would you differentiate the atomic size? So you just focus on the proton number. So which one has more proton number? magnesium, right? Magnesium has 12 proton number. So that's why we said that the positive charge of the nucleus in which atom is higher? In magnesium atom. So when the positive charge of the nucleus is higher, what happened here? We said that the force of attraction of the nucleus on the electron is stronger, and it will pull the electron closer to the nucleus, and this causes the atomic size of which atom to be smaller. In this case, we say that magnesium. So the force of attraction is stronger, force of attraction of the nucleus is stronger, and then this causes the atomic size to be smaller because electrons will be pulled closer to the nucleus. Next, electronegativity. So this is the second thing I want you to remember today. So moving from left to the right of a period, the electronegativity increases. So what do you understand by electronegativity? So look at the term negative. So it is the strength of an atom to form negative ion. So I would like to tell you. So many of the many reference books is just write down it is the tendency of an atom to form negative ion. But I use this word strength because most of my students they don't know the term tendency. So that's why I use it. I use this one. I write it in this way. The strength of an atom to form negative ion. So that means if an atom will need to form negative ion, it must receive electron, right? Because electron carry negative charge. So always remember, if an atom can receive electron easily, it has higher electronegativity. I repeat, if an atom can receive electron easily, it has higher electronegativity. So now let us compare phosphorus and chlorine. So the electronegativity of phosphorus is 2.1 and then the electronegativity for chlorine is 3.0. So we said that which one can receive electron easier? Chlorine, because the strength of chlorine atom to form negative ion is higher. So that's why we say it receives electron more readily than phosphorus. So that is the second thing you have to remember. So now let me show you another example. Actually, this example is just the same as the example in example number 1. But my question is, which one is more electronegative? So I show you two atoms here. So which one is more electronegative? Can you figure it out? So just now you learned that from moving from left to the right of the period, in a period, the electronegativity will increase. So now we know that chlorine has higher electronegativity. But how would you explain? How would you explain in the exam? So it is just the same explanation as we discussed just now. So we said that the positive charge of the nucleus in chlorine atom is higher because the proton number is higher. So the force of attraction of the nucleus on the electron is stronger. So once the force of attraction of the nucleus on the electron is stronger, it will cause the atomic size of chlorine become smaller, and it is easier for the chlorine atom to receive one more electron compared to sodium atom. So if chlorine atom can receive electron more readily, we say that chlorine has higher electronegativity, or we say that chlorine is more electronegative than sodium. For the third part, so when moving from the left to the right in a period, you will find that the elements at the left hand side are considered as metals. So we just focus on period 3, sodium, magnesium and aluminium. These three elements are known as metals, followed by silicon. Silicon is known as metalloid, and then phosphorus, sulfur, chlorine and argon. These four are considered as nonmetals. So you are familiar with metals and nonmetals, but what is metalloid? So actually metalloid is semi-metal. So it shows both metal and non-metal properties. So actually metalloid is a weak electrical conductor. However, the electrical conductivity can be increased by adding impurities such as boron and phosphorus. And another way is you can increase the temperature of the metalloid. So uses of metalloid, it can be used as diodes and transistor. So both diode and transistors are very commonly used in making of microchips. And then you will actually find the microchips in your mobile phones, televisions, video recorders, calculators, and etc. So many electrical appliances. Next, we focus on the oxide of the element. Oxide of the element in period 3. So we have sodium oxide, we have magnesium oxide, aluminum oxide, silicon oxide, phosphorus pentoxide, sulfur dioxide, and dichlorine heptoxide. Now maybe some of you will ask, hey teacher, where is the oxide of element argon? Where is argon oxide? So do you still remember? Argon is very stable and it exists as monoatomic, which means it does not react with any other atoms. So remember, so we don't have argon oxide in chemistry, right? Remember. So now, given that sodium oxide and magnesium oxide are basic oxide, so what will happen? So now imagine that we are carrying out the simple activity in the experiment in the lab. So I pour in some acid and then I add in oxide. So now I add sodium oxide and magnesium oxide. So of course I start with sodium oxide first. When I add sodium oxide and then I shake it. So do you think that basic oxide will react with acid? Yes, it will react with acid. So you learned this one in Form 2, right? So it will react with acid. So how about magnesium oxide? If magnesium oxide is a basic oxide, so I pour in some acid and then I add 2 spatula of magnesium oxide. Any reaction take place? Yes, it will react with acid. And then aluminum oxide, it will react with acid as well. But now, look at this one, acidic oxide. So if I pour in acid and then I add silicon oxide into the test tube and then I shake it. Maybe I just shake for 1 day maybe. So do you think that there is any reaction here? Any observation here? No. Yes, that means silicon oxide does not dissolve in acid. That means it is an acidic oxide. So of course, if it is acidic oxide, it won't dissolve in acid. Sulfur dioxide, it won't dissolve in acid. Dichlorine heptoxide won't dissolve in acid. And now, how about alkali? So now I change it. So I add some basic oxide into the alkali. So do you think that there is any reaction here? So basic oxide. So now I change it to alkali. No, it won't have any reaction. So no, it doesn't have any reaction. And the aluminum oxide, yes, it reacts and then it dissolves in alkali. Sulfur oxide, no, yes, because it is an acidic oxide. And then acidic oxide, it will react with alkali, it will dissolve. Sulfur dioxide will dissolve, and then dichlorine heptoxide, it will dissolve as well. So now we have another special case here. So do you notice that aluminum oxide, it will react with both acid and both alkali? So should I consider it as basic oxide? Or should I consider it as acidic oxide? So which one actually? So sometimes it can react with acid, sometimes it can react with base. So in this case, we name it as amphoteric. So amphoteric oxide, it is the oxide that can react with both acid and alkali, remember. So in SPM level, when you mention about amphoteric oxide, so it refers to aluminum oxide. So remember today, what is amphoteric oxide? That is the oxide that can react with both acid and alkali. So summary. So the first thing I want you to remember, across the period, the atomic size becomes smaller. So you should be able to give the explanation because the proton number increases by 1 unit the element to the next element. So the positive charge of the nucleus increases and then the force of attraction of the nucleus on the electron increases. So that's why electrons are pulled closer to the nucleus. So next, so for the second part of the lesson today, across the period, the electronegativity increases. So what do you understand by electronegativity? It is a strength of an atom to form to form negative ion. To form negative ion by receiving electrons. So the explanations would be the same. The proton number increases when we move from the left hand side to the right hand side of the nucleus of the period. So the positive charge of the nucleus increases and the atomic size decreases. So the force of attraction of the nucleus on the electron increases. So this causes it is easier for the atom to receive electrons. So that's why electronegativity increases. So next, moving from left hand side to the right hand side, so we said that sodium, magnesium, and aluminium are known as metals, and the silicon is known as metalloid. Phosphorus, sulfur, and chlorine and argon are known as nonmetals. And then the last part, you have this very special name here, amphoteric oxide. So once we mention about amphoteric oxide, it refers to the oxide that can react with both acid and alkali. And then in SPM level, we just have one amphoteric oxide, which is aluminum oxide. And then the oxide of the element at the left hand side, the oxide of the element at the left hand side of the period is basic oxide. And after amphoteric oxide, we have acidic oxide. And remember, we don't have argon oxide because argon is very stable and it won't react with any atoms of element. So that's all for today. Thanks for watching.